the 5-number summary in statistics is a statement of basically the quartiles and the median and the min and the max in order from smallest to largest. Basically what you would do is you'd list what's the smallest data point, what's the first quartile, what's the second quartile, aka median, what's the third quartile, and then what is the maximum. And what the whole idea of the 5-number summary is, it's a description of this data without having to list all of the data. It's sort of a overview of here's the smallest, here's the largest, here's the kind of those centralized 25%, 50%, 75% lines. Just kind of another way of, so like imagine you had a set of data with 1,000 entries. Looking through all the data could be impossible just to try to understand it. But if you have those 5-number summaries, you get a pretty good sense of where the data is based on those numbers. So let's go ahead and write out the 5-number summary for our age and our GPA. Again, sticking with the same data that we've been working on. So for our ages, we listed them all out on the previous page, as you can see here, but our median was 19.5. We found our first quartile to be 19 and our third quartile to be 25, which again is like the median of the left group, first quartile, median of the right group, third quartile. And so basically the 5-number summary will include all of those all those three things. So 19, 19.5, 23, but it will also start with the smallest and end with the largest. So let's go ahead and write that out, and that will be our complete 5-number summary for our age. And I'll just go ahead and note this over here. I'm sorry, my tablet is being silly. I think I've got it figured out now. Ready to go. Okay, so let's go ahead and write out that 5-number summary. Age, and I'll just make a little line here. So the minimum age was 18. Our first quartile, we had 19. Our median was 19.5. Third quartile, I already forget, was 23. And then our max was 37. And again, when you're looking at 5-number summaries, it gives you kind of an idea of what's going on. Notably, the mean is not part of this, though. Just the medians and quartiles and whatnot. And then for our GPA, we had our mean GPA was 3.55, or median GPA was 3.55. Our first quartile, 2.5 and 3.8. Let's go ahead and just note this as well. GPA, median was 3.55. 3.8 was our third quartile. And again, I forget already, too many numbers. It was 2.5. Yeah, it was our first quartile for our GPA. And then our minimum GPA of our sample was 2.2, and our maximum was 3.9. And again, we can see in some cases the median is much closer to the third quartile and to the maximum. Sometimes the median is closer to the first quartile, or the minimum. It just depends on the data set, depends on how it is skewed. And if we recall, based on some of the graphs we made earlier, our age was skewed a little bit towards the left-hand side, and that comes up when we're looking at our 5-number summary. And we didn't make a graph for our GPA, but the GPA, more of that data tended to be congregated in the 3 bracket than the 2 bracket. So this histogram is a bit bigger, which is why our median and our quartiles are more emphasized in those numbers instead. Now, along with the 5-number summary, it's worth talking about the interquartile range. And what the book calls the 1.5 times IQR rule. I just wanted to get into this a little bit. So the interquartile range is defined again in the textbook, but the snippet I put in your packet, it says it's the distance between the first and the third quartiles. So let's go ahead and figure out, well, what is the IQR, aka interquartile range, for age? Let's just say the IQR for the age. And that would just be equal to the third quartile minus the first quartile, which we calculated again in the last video, but oops, I threw my pen on accident. I'm down here. There we go, I got it. But yeah, that would be 23 minus 19, quartile 3 minus quartile 1, which gives us 4. And basically, it's the difference between those. And recall the first quartile was like the 25% mark. The third quartile was the 75% mark. So it gives us kind of an idea of how wide is our center here. Because half of the data lies between these points, because that's the 25 and 75 mark. And the interquartile range describes, well, how big is that? For the age, it wasn't a very, very big margin, because most of our students were between 19 and 23. Half of them were in this particular case. And it just that's what the IQR describes. Let's also look at the interquartile range for the GPA as well. And the third quartile GPA was 3.8, first was 2.5. So the IQR for the GPA would be 3.8 minus 2.5, 1.3. And, well, it's technically a smaller number than our age. Since the GPAs were much smaller numbers, I would say that it's sort of a wider range here, based on the context of the size of the numbers, which you could figure out by dividing by the scope, but I don't need to get overly complicated here. But basically, this is kind of saying that the width of our GPA for that, the center of the data for the 50% in the middle is 1.3, a pretty big margin of GPA, I would say. Whereas the age margin, based on the size of the ages, was not very big. So last but not least, to wrap up this video, what we call the 1.5 IQR rule, I didn't actually put it in our packet, but basically it's a standardized way of defining what an outlier is. So the 1.5 times IQR rule says that any data point which is more than 1.5 times the IQR away from the interquartile range is called an outlier. So that's, saying it probably was a little bit hard to follow exactly what I mean here. So let's just look at this and see for the particular data points. But basically, for age, our interquartile range was between 19 and 23. And if any data point is far away from that, that's sort of all the data in the middle. And if anything is far away, we call it an outlier. But basically, the 1.5 times IQR rule says, well, how far away does it have to be considered an outlier? And again, if you're wondering why is it 1.5, because some of you probably don't care, but some of us always want to know, well, why? It's just sort of a standardized margin for defining how far away it needs to be. And there's a reason why 1.5 makes sense, but technically, you could do a different number as the basis of the outlier, because how far does far away need to be far away, if you see what I'm saying. But let's not get overly philosophical here. But anyways, so if you take the IQR and multiply by 1.5, so 1.5 times IQR, well, for the age, that would be 1.5 times 4. 1.5 times 4 is 6. So basically, if it is more than 6 units, or in this case, years away from the from that interquartile range, or from the quartile 1 to quartile 3, then it will be an outlier. And so this is kind of like the margin for how far away it would need to be. And for GPA, if you take 1.5 times 1.3, that would give us our margin for being an outlier. So 1.5 times 1.3, which would be 1.95. And this would give us our 1.5 times IQR rule margin. So, well, how do we actually find an outlier? And this is kind of the last thing it says. It says discuss potential outliers in our examples. And graphically speaking, when we were talking about, I brought up the term outlier before, but this is a way to sort of quantitatively determine whether something's an outlier. Like in the case of our age groups, we had most of our students were between the ages of 18 to 25. We had one student who was 37. That's kind of like a lot, pretty different from our data. But basically, we can now say, how do I know if they're an outlier from the 1.5 times IQR rule? And in this case, the quartile 1 was 19, quartile 3 was 23. And 37 is way far away from 23. In this case, 6 is our 1.5 times IQR. If you were to take Q3 and add the 1.5 times IQR to that would be 29. And any value that's beyond that is considered an outlier. So 37 is much further away from that interquartile range than 29. It's way more than 6 more than 23. And that's why we'd say that 37 is indeed an outlier. So that student, I believe her name was Gladys, was an outlier in the age consideration just because she was much different than her peers. But this is really a way of saying what is how far is far, to be statistically considered an outlier. And again, not that there's anything wrong with being an outlier. Some people don't, we don't always like being different, but it happens. It's not a big deal, but sometimes it's just a way of analyzing those sort of things. Now, what about GPA? Or we could also look at the lower side. So to be an outlier on the lower sense of age, well, 19 was our Q1, and we'd actually want to subtract 6 from that to see what the boundary between an outlier would be on the young side. So 19 minus 6 would be 13. So basically, a student would have had to have been younger than 13 to be considered an outlier. And obviously, for a college student, that would be very uncommon. But it can happen, and they would be an outlier based on this definition using the interquartile range. So anyways, and if you're wondering why was it plus and minus in these different cases, well, it's sort of like you either have to be more than quartile 3 by that much or less than quartile 1. It's like you have to be far away. So, to go to the left, you want to subtract. To go to the right, you want to add, if that makes sense. And for GPA, in order to be an outlier, you have to be more like almost, let's just say 2 GPA points away from the the quartile 1 and quartile 3 in order to be an outlier. So you'd have to take this and add 1.95. That would mean the GPA would have to be something like 5.7 to be an outlier on the positive side, which is impossible. So basically, we don't have any outliers for GPA. Even on the lower side, because if you take 2.5 and subtract 1.95, that would put you at, you would have to have a GPA of about 0.5 something, 0.55 in order to be considered an outlier, which we don't have. So we'd say that there are no outliers on the GPA scale, and there is only one outlier under the age consideration.